Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we'll discuss about the wireless Ethernet. Okay, before this, we talk about the Ethernet evolution. We have the standard, the fast, the 1 gigabit Ethernet, the 10 gigabit Ethernet. So this video will discuss about the wireless Ethernet. IEEE has defined the specification for a wireless LAN called IEEE 802.11. You can check at your laptop, you can check at your router, you can check at your smartphone. What are the standard? And usually you will find the standard is equal to 802.11. It based on the 802. So this standard cover the physical and the data link layer under the OSI and Internet model. Okay, the first part we go for the architecture for the wireless. Okay, a BSS without an AP is called an ad hoc network. This one is type of the architecture for the network, and a BSS with an AP is called an infrastructure network. What is AP? AP is referred to the access point. So when we have a connecting devices using access point, we call it as ad hoc network. And without the access point, we call it as the ad hoc network. If we have the access point, so we call it as infrastructure network. So this one, BSS refer to the basic service set. Okay, basic service set. So refer to the building block of wireless LAN, and AP access point, optional central base station. So this is ad hoc network without the AP, but you still can connect it together to each other. Okay, this one is the infrastructure network, BSS with the AP, so everyone can connect to the AP in order to connect to others PC. Okay, these are the architecture of the wireless network, wireless Ethernet. Okay, the next one we have the ESS. And ESS is made up of 2 or more BSS with AP. So BSS are connected through a distribution system. Usually we use the wireless LAN, and 2 type of station, mobile station inside the BSS, and the stationary AP station that part of the wired LAN. A mobile station can belong to more than one BSS at the same time. So this is the ESS, extended service set. Before this is the basic service set. This one is the extended, called as ESS. So the extended service set, ESS, BSS basic service set, AP is the access point. So the different, we have multiple BSS with APs connect to the distribution system, and this distribution system connect to the server or the gateway. This architecture we call as the ESS. So no transition mobility, either the stationary not moving or the station moving only inside a BSS. Only inside a BSS. So it's only moving inside the BSS, we call as no transition mobility. BSS transition mobility, station can move from one BSS to another BSS, but it's still inside the ESS. Here refer to this one. Station can move from one BSS to another BSS, but still in the SIM of the ESS. And ESS transmission mobility, station can move from one ESS to another ESS. So this one is referred to the type of station inside the wireless Ethernet. Now we look for the MAC sublayers in the IEEE 802.11 standard. So it's still play around or discuss about the data link and the physical layers. So we have the LLC, And we have the MAC sublayer at this part. Okay, under the MAC sublayer, we have PCF, point coordination function, and we have distributed coordination function, DCF. In this one, LLC sublayer IEEE 802.1. For the physical layer, we have the FHS, DSS. This one is a spread spectrum, infrared DSS, or FDM, and DSS. Okay, this one refer to the G refer to the Bluetooth. Okay, under the DCF, distributed coordination function, this one is use CSMA collision above void. So CSMA/CA as the access method. Accessing multiple method, if you still remember that part. Okay, wireless LAN cannot implement the CSMA/CD for 3 reasons. In wireless communication, if you want to implement the multiple access, we choose the CSMA/CA, not the CSMA/CD. CD is referred to collision detection. CA avoid collision. Okay, why we cannot implement the CSMA/CD for the wireless line? The first, for collision detection, a station must send and receive data at the same time. Okay, this one is costly and will increase the bandwidth of the network. The second, collision cannot be detected because of the hidden station problem. Yeah, when we talk about the wireless communication connection, we can have one problem that we call as hidden station. So that's why we cannot implement the CSMA/CD under the wireless. And the third one, distance between station can be great. Signal fading. It will cause the signal fading when it travel throughout the air. That's why we cannot use the CSMA/CD. So CSMA process flowchart. If you still remember, CSMA refer to the sense multiple access, means carrier sense multiple access means that you need to listen before you can talk. You need to sense before you can send the data. So start at here, set back off to the 0. It is the persistent strategy. Wait the IFS and then send the RTS, set a timer, and then CTF receive before timeout. If yes, wait for the SIFS, send the frame, set the timer, acknowledgement, receive before the timeout. If yes, then success of your transmission. Otherwise, you need to increment the back off, wait for certain time, and repeat again the process. This is the process on how to sending a frame when you have the frame. So CSMA, CE, and network allocation vector, NAV. It is show you about the CSMA. So source and the destination. At this part, there is no carrier sense. There is no sense to the transmission medium. This one is source, this one is destination. It send the RTS and then it reply with the CTS. So this one is ready for the sending the data. After the destination receive the data, it will send the acknowledgement. I already received the data. For point coordination function, PCF, an optional access method, this one implemented in an infrastructure network. So this one is under the wireless connectivity with the AP access point. It is mostly for time sensitive transmission. And then centralized contention free polling access method. Station are polled one after another, sending data to the AP. So it uses the polling function. CIFS is the same as the DCF, and PIFS is shorter than the DIFS. So AP has the priority to send and receive. So example of the repetition interval. Okay, this one, the repetition interval has been designed to cover both contention free under the NAV when there is no station sends to the transmission medium, PCF and contention based DCF traffic. Okay, it look like this one. So we have AP, we have the pole station, and we have the other station. For the frame format, MAC layer frame consists of 9 fields of the segmentation. We have FC, D, address 1, address 2, address 3, SC, address 4, frame body, and FCF. This one for the data. So total here, we have 2 byte, 2 byte, 6 byte, 6 byte, 6 byte for the address. So total for address, we have 18 byte. For the SC, we have 2 byte. So until this part, we have 18, 20, 24, 30, 34 without the data. So 24. So the frame body, the minimum size is 0. The maximum size is 2312 bytes. So the FC define the type of frame and some control information for this frame. For this part, D define the duration of the transmission that used in order to set the value of NAV. Addresses, we have 3 addresses here. There are 4 addresses field, depends on the value to DS and from DS. Depends on how many destination and sources that we have inside our network. Okay, the next one, we have the AC, the sequence control. Define the sequence number of the frame to be used in the flow control. We have the frame body, contain the size of data. This one between 0 until 2312 byte. And then we have the FCS, contain a CRC, area detection sequence. So this one is the frame format under the MAC layers. Okay, the wireless LAN under IEEE 802.11 has 3 categories of frame. We have management frame, control frame, and the data frame. So management frame are used for initial communication between the station and the access point. The control frame are used for accessing the channel and acknowledging the frame given the acknowledgement. And the data frame are used for carrying data and control the information. So basically in wireless Ethernet, we have 3 types of frame: management frame, control frame, and data frame. So this is the type of format for the frames. Okay, the next video will discuss about the address mechanism. We have 4 cases. So this explanation will be explained in the next video. So until this part, you should know about the wireless architecture. Categories of frame under the wireless LAN 802.11. The 9 segmentation or 9 field inside the MAC layer frame. The PCF, the NAV technique, and then CSMA CA. Wireless LAN only use the CSMA CA for the multiple access. Okay, these are the reason why we cannot implement the CSMA CD for the wireless Ethernet. So basically, you should know the architecture. You should know how to explain this part, the BSS, the ESS, extended, and the basic, how to differentiate this part. What type of station? Okay, we have node transition mobility, BSS transition mobility, and ESS transition mobility. The layers include in the wireless IEEE standard, the data link layer, the physical layers. Okay, and the general format of the frame. So that's all. Thank you and Assalamualaikum.